Okay, so when we're writing ionic formulas, remember ionic compounds, what are they between? What makes it ionic? So it's charged cation to anion, but what typically participate in ionic compounds? Metal to nonmetal, or polyatomic ion to polyatomic ion, or usually metal to polyatomic ion. So when we write formulas, this is ionic formulas, that is. We need to write the cation first. The cation is the one that it's going to be the metal, or what's the only positive polyatomic ion we have? Excellent. Ammonium, yep. So it's going to be the metal or ammonium. When you write the formula, you want to omit charges. So I don't want to see a formula that looks like, that's not a formula. Okay? Now, number 3 can sometimes be challenging. It just takes a little bit of practice. Use parentheses when more than one polyatomic ion is present. So in this example up here, like if I have iron 3 and hydroxide, what I'm going to do is to write this formula, I'm going to write Fe, that would just be 1, and then OH 3. I used a parentheses here because there's more than one polyatomic ion that's required. So I need 3 hydroxides in order to get a neutral charge on this ionic compound. Now let's say it was between like sodium and hydroxide. I just will break down the ones. So 1, 1. So it's just going to be NaOH. I don't need to put a parentheses around this hydroxide because I'm only bringing 1. So I only use parentheses if I use more than 1.
So on the aluminum sulfur one, should I have parentheses?
It's not a polyatomic ion.
So only the
Only polyatomic ions get parentheses. They're so important. Yes. So what happens a lot of times is students will either over parenthesize or under parenthesize. One extreme or the other, and then eventually they'll get it figured out. But in the beginning, it definitely takes a lot of practice. Okay. Ionic formulas are the simplest ratio of ions. Ionic formulas are the simplest ratio of ions. So let's say I come up with, so I have Pb 4 plus O 2 minus. I want to have a neutral compound. So when I do the cross and drop, what's that going to look like? But if I do the cross and drop, that takes care of the charges. That does the math for you. So Pb 2 O 4. I'm bringing 2 times positive 4, which is positive 8. I'm bringing 4 times negative 2, which is negative 8. So the nice thing about the cross and drop is it does the math for you.
And we don't need to show that in it.
No. But if you're like, what? Is this right? You can always prove it to yourself. Okay. Now, so look at number 4. Ionic formulas are the simplest ratio of ions. This ratio right here, can that be simplified further?
Yes.
Yes. How would I simplify it?
We could divide the 2 so that way
divide 2 on both sides, which makes the PB1 and then the oxygen 2, which is the lowest part.
So that's the simplest ratio of ions. If you left it in its unsimplified state, PB2O4, then it might be, you might get half off, whatever the points were. Usually writing formulas is about 3 points, so I might give you 2 to 3 points, something like that. Okay. Now we're going to practice. We're going to practice a lot. Because this is something that makes a lot more sense when you practice it a lot. All right, so if you turn to the next page, see I have this giant table. And on the left side, I have cations. And on the top right, I have anions. So in space number 1, for instance, I'm going to have sodium and chloride combining. I want you to write their formula. So this is primarily intended to help you get practice writing neutral ionic compounds. So using the cross and drop is what I want you to do. If it's a 1-to-1 ratio like number 1, what would your formula be?
NaCl.
NaCl. Good. All right, let's go to number 16. Okay, so you're going to have potassium ion combining with sulfate ion. You do the cross and drop. And how many potassium ions would I need? 2. So it's going to be K2. And then how many sulfate ions like? SO4, so just 1.
So you would have that been more, like say that you needed 2 of the,
Polyatomic ion sulfate?
yes. Then would it be 8? SO8 because you double it?
You would put that, whatever number you needed, outside the parentheses.
Oh, so it would be like, you can't, but it would be like SO4 in the parentheses and then 2 outside?
Yes. I'll do another example for you where that would work. So I do not use the parentheses here because there's only 1 polyatomic ion. Let's do number 23. So calcium and phosphate.
Oh, I have a question.
Sure.
Why wouldn't you simplify
Good question. Why wouldn't you simplify this? You know, when you, I think you always hear this relationship advice, if somebody's trying to change you, run, right? By simplifying sulfate, you're trying to change sulfate. Trying to change who he is.
So that's like, since the polyatomic ion,
Right.
it's like
So you can't touch the SO4 because that would change. He's no longer sulfate, right?
if there's ever a number in the lower part, are we gonna
Yes,
shift it?
if there's a number outside the parentheses, that can be simplified because that's not changing who sulfate is. Yeah, I know it's so cheesy, but I hope it's memorable.
Yeah.
Okay, so number 23, we have calcium ion combining with phosphate ion. You're going to do the cross and drop, and the math is magically taken care of for you. Thank goodness. Okay, so you end up with Ca3, and I need 2 phosphates. So I'm not just going to put PO42. This is when I have more than 1 polyatomic ion, I need a parentheses. And the parentheses goes around the polyatomic ion, so it holds it together. And what you're saying is that for this formula, I need 2 units of phosphate. If I don't use the parentheses, then it's unclear what you need 2 of. So that's how you work the parentheses.
So getting rid of that charge does not change.
Right. Yeah. Okay, so I want you to continue to practice these. I'm going to be wandering around. I will say, I'm going to put asterisks by all your polyatomic ions. Polyatomic ion, carbonate. The next one, hydroxide. Hydroxide often doesn't get the respect that he needs because he is a polyatomic ion. So I say that kind of as a warning. Let's go to number 20. Let's do 21. So Ca2 plus, like that. Oftentimes I'll get students who write this, CaOH2.
I don't understand why that's. So, these CA purposes so there's
Because otherwise you're just saying that the hydrogen has two.
You're not saying 2 hydroxide units. Yes, so that's a huge part. So be sure that you respect the fact that hydroxide is a polyatomic ion. And use those parentheses when you have more than one polyatomic ion. The other polyatomic ions that we have, sulfate, phosphate, nitrate. So be sure you use parentheses when you have more than one polyatomic ion. And ammonium too, thank you. Yes. All right, so get crossing and dropping. Okay, so keep working on these. Now we're going to learn how to name. And I have some students that really like naming. I have some students who really like writing formulas. I have some students that like both, but usually there is a preference one way or the other. So if you prefer one or the other, just make sure you practice the one that you don't like more. Okay, so cations, cations, right? These are the ones that are positively charged. So we're going to learn how to name the ions, then we're going to learn how to name the compounds. So remember that ionic compounds are made up of ions. So metal group ions, groups 1, 2, and 3, are named by listing the metal followed by the ion. So the word ion. So what's the charge on potassium when it forms an ion? +1, good, or 1 plus. What about magnesium? 2 plus. What about aluminum? 3 plus, good. Okay, so it's potassium ion. That's how you name it. So that's pretty good, right? Magnesium is just magnesium ion. But
What's the catch?
if you leave off ion,
It's not the same thing.
it's not the same thing. So if you just say magnesium, I'm going to think, oh, they're talking about magnesium, like just the metal, the neutral metal. They're not talking about the ion. So magnesium ion. And then the last one is aluminum ion. Good. So the main group metals are pretty straightforward to name. You just, if you have an ion, you just name it whatever the metal is plus the word ion. If you leave off ion, then you might get a half point off. Okay, transition metals can be named 2 ways. Now remember the thing that's special about transition metals. Transition metals can't make up their mind about what charge they're going to be. There are a few transition metals that have their stuff together and know who they are. But there are some transition metals that don't. Let's see what example. Okay, let's look at chromium. I'm going to really, chromium is going to come and get you. Okay, so chromium, atomic number 24, there are 3 numbers written above chromium. These are the possible charges that chromium can be. So chromium's not sure what he's going to be when he grows up, right? It can either be a +3, a +6, or a +2. We don't see +6 with our examples, so I'm going to just cross off +6. Okay, so we have Chromium can be +3 or +2. It depends on what he wants to be for the day. Based on the formula for the compound, you can always tell whether chromium is +3 or +2. But there's a different way to name it. You can't just say chromium ion. Because if you said chromium ion, you called up a company and said, I would like a solution of chromium ion, they'd say, well, which chromium ion do you want? Do you want +2 or do you want +3? So then you need to say, I want chromium 2 ion or chromium 3 ion. Or you could say, if you wanted to be really fancy, you could say, I want chromous ion or I want chromic ion. Okay, so let's go. I'm going to teach you the IIU Pack way first. And remember that IIU Pack stands for the International Union of Pure and Applied Chemistry.
Well,
It's just a convention that they all these chemists get together every year and they agree on how to name everything. So they have a consistent way. So usually what you'll find with nomenclature, whether it be organic, whether it be inorganic, there are two ways to name it. There's the old way and the new way. So the IIU Pack is the newer way. So the way you name it, but I think it's easier, is you just put the metal name and then a Roman numeral indicating the charge and then the word ion. So this guy right here would just be called chromium 2 ion. So if you called up that chemical supplier and you said, I would like a solution of chromium 2 ion, they would know exactly what you're talking about and hopefully would be able to ship you the right chemical.
So the common, is that what you already have there?
I don't have the common yet, so I'll cover the common in just a minute. How would you name Cr3+?
chromium 3.
Chromium 3 ion. Good. So the common nomenclature. This is the older nomenclature, and what had started to happen was there were several different ways to name things depending on where you were. So there was lots of confusion. So that's why IIU Pack came around and made everything consistent. So the common way, the lower charge, you add us to the ending. The higher charge, you add ic to the ending. So this would be chromous ion, and this would be chromic ion.
So what is
Chromous ion, chromic ion. I always think IIU Pack is a lot easier because you have the Roman numeral telling you definitively what that charge is. With the common nomenclature, you really have to use your periodic table. And in Principles of Chemistry, which is chem100unit2pages10thru14, we use the same periodic table, which has the transition metal charges written. In chem100unit2pages10thru14, they don't do that. So you have to kind of have these memorized. But don't worry about it for this class. Yes, Angela.
So the common names, are those only in relation to each other? Because technically it says on here that the highest it can be is 6.
Mm-hmm.
So would that be chromus?
So you are highlighting one of the limitations to the common nomenclature.
Okay.
So a long time ago, they didn't realize that chromium could form a +6 as well.
Mm-hmm.
So when it was just 2, so that's another problem with it. So you'll see, like I'll take out a few other 6s, like iron, so that you don't get confused and think that's iron +6.
Okay.
Actually, while I'm thinking of that, let's do that for iron too. Number 26, go ahead and cross out the number 6. And somebody's done it on this periodic table.
So there's just really uncommon, is that what that one is?
Yeah, I mean, it exists, but we don't. We just omit it for our purposes. Makes it easier. So, now we're going to learn how to name the anions. Now, I think anions are a lot easier than cations. So, anions have what charge? A positive or a negative charge? Negative charge. Good. Okay, anions are named by replacing the ending of the element with "ide" followed by the word ion. So, let's go ahead and fill in all the charges that these atoms would form. So the ions, what ions would each of these form?
-1.
Good. And so you would just call that, so the ending of the element, so bromine, you're going to replace the ending of the element with "ide," bromide, and then say the word ion. So this would be bromide ion.
So that would be the whole answer is the symbol, the charge, and then the new name with the ion?
Correct. All right, what about O? What's the charge? Mm-hmm. And how would you name it?
Oxide.
Oxide. Good. Oxide ion.
Oh, wow, okay. Well, it's all clicking from what you had to summarize.
Mm-hmm. Good. That's good. I love it when it clicks. Okay, S2 minus. So this would be sulfide, yeah. What ion does nitrogen form? Nitride ion, good. Mm-hmm. And then what about phosphorus? What ion does this charge? Or form? Re negative, yes. How would you name it?
Phosphide.
Okay. Phosphide ion. Yes, half point off. Okay, I want to point out here, we have some similarities in names with the polyatomic ions, but they're not the same. So anytime you have an "ide," it comes from the nonmetals. Yes, yeah, so, and you have hydroxide too. But this is nitride, oxide, fluoride, phosphide, sulfide, chloride, bromide, iodide. Sometimes students will get sulfide confused with not the same thing. That's sulfite ion. So this is sulfite ion. Nitride is not the same as nitrite ion. So I'm not trying to confuse you, just the opposite. I'm trying to avoid confusion, but sometimes when I do that, it creates more confusion. So hopefully that's not the case. Phosphide ion is not the same as phosphate ion. Okay. Questions? Let's go on. So we've learned how to name ions. Now we're going to learn how to name ionic compounds. So with ionic compounds, let's do a little flow chart again. So you have a metal to a non-metal, or polyatomic ion to a polyatomic ion.
What do you mean by that? Okay, I like that.
Just that they're bonded together. They're in a bond.
Oh,
They're in an
okay.
ionic compound.
Okay. So
One.
could I just write an and symbol there?
Mhm. Or you can have a metal to a polyatomic ion, something like that. So anytime you have an ionic compound that's made up of a cation and an anion, it can be one of two things. You can have a main group metal to a nonmetal. So this is just one ion, right? Group 1, 2, or 3.
So those two together.
So an example would be lithium fluoride. There's just one ion for lithium. It's not one of those transition metals that doesn't know what he's going to be. It's, I'm lithium, I have +1 charge. Okay? Same with fluoride. Fluoride's -1. Okay, the other scenario that you can have is a transition metal. And a nonmetal. Now the transition metal can have more than one ion. So an example of this would be like chromium 3 chloride or chromium 2 chloride. Chromium can either be +3 or +2. So this would be chromium 3 chloride. This will be chromium 2 chloride. Okay. Questions on those?
When you say that the transition metal has more than one ion, does that mean that the compound has more than one ion?
No, the element is capable of having more than one ion.
Oh, okay, because that's, you're saying like everybody in group 1 only has that one type of ion.
Mhm.
So you're just emphasizing that transition metals could have various options.
Right.
Okay.
Mhm.
How come you wrote the 2 after chromium instead of chloride though?
Did we do the cross and drop?
That's it for you?
Yeah. No, you haven't forgot already. No.
I just forgot to do it. I didn't notice because I didn't see it before.
Right, so you do.
So do you just do the cross drop for all ions?
All ionic compounds, yep. Lithium would be +1, fluoride would be -1. So cross and drop like that.
Chromium 3 chloride.
Is that how you would say it?
Yes. So when you call the chemical supplier, I would like to purchase some chromium 3 chloride. If you just said, I would like to purchase some chromium chloride, they're going to look at you like you're nuts. Excuse me? You don't know what you're talking about. I'm not going to sell you chemicals, right?
That would make sense. Okay. So when you name it, you're referring to what it looks like before you do the crossing guard.
Correct.
The common naming.
This one is actually IIU Pack because it has the Roman numerals. And I'm just giving you a preview. We're still kind of getting into naming ionic compounds. This one, named the old way, would be chromic chloride. This one would be chromous chloride.
And it would be chromic because it has the higher charge of
Right.
nothing has its lower.
Very good. Mm-hmm.
Are we gonna practice these more? There they are.
Of course. Practice makes perfect. Okay, so some metals that form more than one charge. Ferrous, ferric. Ferrous is iron. So this is, so I want you to look up iron. Tell me what charges iron can have.
3 and 2.
3 and
Because
2.
we crossed out the 6.
You crossed out the 6. Okay, so ferrous is going to be Fe2 plus. Ferric is going to be Fe3 plus. Plus, right. So I want you to work on filling these out. And I'll put cuprous, cupric, that's copper, orus, auric, this is gold, stannous, stannic, that's tin, Sn, plumbus, plumbic, that's lead, Pb, chromis, it's derived from Latin and Greek names.
And then some of them got to the point where they started to name after themselves rather than the country, so that's why they're inconsistent.
Right, like Californium.
It's just like, why is Ferris on there? Okay.
I found one name before that.
Okay, so what did you get for, okay, cuprous, cupric. Cuprous would be,
+1.
and
Cooper +2.
good. All right, orus, auric.
+1.
So you can kind of see they're not all predictable. Like it would be really easy if they were all +2, +3. But it depends on the transition level.
So if you just put plus instead of +1.
That's fine. All right, stannous, stannic.
+2. These could be people's names.
Stairs.
I know, I always joke about children's names, like, especially when you get to organic chemistry, but inorganic chemistry.
Oh, yeah?
Yeah.
I like these ones, though.
Yeah.
Plumbus.
Plumbus.
Columbus. It's kind of a fat name. You're like a name. I don't know.
I just love that word.
+2 +4.
Yes.
Cracks me up almost as much as the word
What was it?
+2 +3.
Cooperative.
God, I
That's
guess.
kind of a gross word.
I just think it's the funniest word in the world. We're sort of every joke for like 3 days.
That's funny. All right, Mercurus is
+1 +2.
good. All right, so we've learned how to name the transition metals, the main group metals, the anions. Now we're going to put it all together. So ionic compounds are named by listing the cation name. And if you have a transition metal, don't forget the Roman numeral or the us or the ik, followed by the anion name. Note, the word ion never appears in the name of ionic compound.
Which makes no sense.
So, okay, let's see. Which sounds better? Okay, sodium ion, chloride ion, or just sodium chloride.
Well, at least the ion would be an indicator.
But you're saying a metal to a non-metal. That's an indication of an ion compound.
So when they're listed by themselves, so say you have a sodium ion, okay.
But if you did just had Na plus just by itself, that would be sodium ion.
Okay, but when you have,
Then together, and it's neutral, and you did the cross and drop,
okay,
no ion.
Because we're neutral.
So this is the cation, what we just did up here, right?
Right.
I just feel like chloride, it's kind of clear that it's an ion because it's chloride, not chlorine.
Yeah, and
So
that's
you need the chloride ion, it's just chloride.
all right. So let's go to the next page. Okay, so MgCO3.
Magnesium and carbonate.
Magnesium carbonate. You got it. Is magnesium a transition metal?
No.
So I don't need to put a Roman numeral or anything, right? Magnesium carbonate.
How's it pronounced? I've been saying carbonate.
Carbonate.
Okay.
Tomato, tomato. I don't care as how we pronounce it as long as you write it down the right way.
Okay.
How come you put, oh, because that's a
Polyatomic.
a polyatomic compound.
Ion, yep. Okay, what about this one? Ammonium sulfide. Okay.
So, copper? How do we know it's
How do we know which copper? So you can do the cross and drop. You can do the cross and raise. So yes.
Copper 2. So it's
So for one copper,
sulfide 2.
Copper 1, copper 2.
I think it's 1 2.
Copper 1. Copper 1. It is copper 1.
Why?
So you got to raise that 1. Cu1 plus S2 minus. That is copper 1. What's the rest of it? Copper 1 sulfide.
Do you need to specify the one, or can you just, is copper the same as copper 1?
So if you just say copper sulfide, I don't know whether it's copper 1 or copper 2. So, always put yourself in the shoes of, I'm trying to call an order of minerals. Do they know what I'm talking about? So with transition metals, unless the transition metal has just one charge, and there are a few that do. So there are a few transition metals that only have one charge. Zinc. So if you called up a company and said, I would like to purchase some zinc chloride, they would know exactly what they're talking about. So you don't need to say zinc 2 chloride. Another one is silver or cadmium or indium. And
so what's the
yttrium, zirconium.
name of the scientist was from India? Because they have a Germite because he was from Germany.
There's americium.
Oh yeah, americium. Okay, so the transition metals that just have one charge don't need a Roman numeral.
I think I'll just order those.
Zinc, silver, cadmium. I don't have privileges to order the other transition.
I don't do chemistry.
No. Yes, Angela.
Why wouldn't it be copperos? cuprous.
Oh, it could be cuprous. So see, there are two ways to name things. And I have students who don't want to embrace the common nomenclature, so they just kind of ignore it.
So which one would be better to know?
Both. I could ask you to write the formula for cuprous sulfide. I could also ask you to write the formula for copper 1 sulfide. And that's what you're going to find with your other chemistry classes too. Knowing both is better. So cuprous sulfide.
In the scientific community, which one is more
IIU Pack is more often used, but there's still some people who like to use the common nomenclature. So that's why we teach it. You know, if you ever come across a chemical that's in the old way, no way to use it.
So all three of these are acceptable to use?
Copper 1 sulfide or cuprous sulfide.
Okay.
But the formula is just explaining why it's copper 1, because it's the reverse of the cross and drop.
All right, so I want you to continue working on those. I'll be wandering around.
Tennis.
Tennis, yeah.
It's not even right, is it?
Go play tennis.
Wait, that is it?
Stannis.
Oh. Okay.
Okay, so this one is iron
2 acetate.
iron 2 acetate, or you could have ferrous acetate. Okay, the next one.
Stainless.
Let's see, 10, 2, phosphide, or stannous phosphide. Now, on a quiz or an exam, I would accept either. So if you prefer, I do have students who prefer the common way. They're kind of old-fashioned. They like to say the us and the ick.
So you said we did the package of it?
I said phosphate.
Right, phosphate is
Phosphate
incorrect.
is a small.
Phide is from the periodic table. It's just phosphorus, the ion of phosphorus. Phosphate is a polyatomic ion, PO4 3 negative. Angela.
For the last one on this, is there only one possible answer?
Yes.
Because those are both polynomial.
Ammonium dichromate.
Which is one that you had us memorize.
Yes. So see, memorize your polyatomic ions. That's huge. Okay, this one is Fe3 plus O2 minus. So this is iron 3 oxide, or ironic
It
oxide.
should be ironic, but it's not because it's ferrous. But
Yes,
Ferric.
ferric oxide. Yeah, I like ironic. And tennis. Tennis phosphide. I like to play tennis, so that's perfect. Okay, so this next one, copper 2 plus, HCO3 negative, so it's copper
copper.
2 bicarbonate, or cupric bicarbonate.
Did you say it could also be hydrogen?
So it could be cupric hydrogen carbonate, or copper 2 hydrogen carbonate. Yeah. You like the longer, more complicated. Okay, so